Hey, what's up everybody? Jesse here in my house by myself this afternoon, which is kind of cool because I've been wanting to shoot a video on my computer here for a while and show you something that I've learned how to do recently and just share the experience with you and show you the result in the end. But basically what we're going to do, long story short, is custom design a jig head, a lead jig head from scratch based on a couple design ideas I had. And I'm going to walk you through how I did it and pretty much show you the ins and outs and the frustrations and the ultimate product at the end of it. So I hope you enjoy it. I'm definitely not the first to do this. I was inspired to do this from some other people on YouTube when I was researching, making jig heads and stuff. And I was like, oh, that's pretty cool. And I actually have everything I needed to do it. First and foremost, I'm going to jump right in on the PC over here, which I got set up, do some screen recording and show you how I designed 2 different jigs so far, pretty much from scratch. So let's jump right into it. All right, folks, so I'm set up on my PC here. I'm gonna kind of be doing picture-in-picture screen capture stuff to just walk you through the process of what I did and make it as quick as possible. I'm not gonna show you every step because the video would be ridiculously long. Like I said, there are other videos out there that kind of do that. I may do another video like that later on. But anyway, basically what I'm starting with here is CAD software, which is called Fusion 360. It's one that I got a while back when I got into 3D printing this winter, which you see my printer over here behind me. And that's kind of what I used to do this. Now some of you may be like, oh, that's crazy, they're so expensive. But honestly, 3D printers nowadays are really cheap. And any entry-level 3D printer that's capable of printing PLA, which all of them are, would be capable of doing this. So I just wanted to share this whole process with you because it was really cool learning it. I'm just going to jump right into the screen recording here. As you see, I have Fusion 360 open. The first thing to doing this is I had to model the actual hooks that I was going to be using, which are these Mustad 32824 2X hooks. I really love these guys because they're so strong. This is an 8.0 hook here. I also used some smaller ones all the way down to like 3.0, 4.0. I basically modeled all the different hook sizes first in the software accurately. And just to show you how I did that, I have a job here open already. This is a hook model, and I'm just going to step you through the steps here at the bottom. You can see all the steps of creating it. First thing I did was I just brought in a picture that I took with my cell phone of the actual hook, nice and straight down, on my phone with a ruler underneath of it for scaling. And basically once you import this picture, you just go up here, insert canvas, and it'll insert the picture into the 3D file, and then you go over here under canvas and you right click on it and you click calibrate, and then you just zoom in, click like 2-inch, these 2 spaces here, and you define that actual distance, which is 1 inch. And I'm just going to back out since that was already done. And once you do that, it basically represents that hook in actual size in the software. So I got that done, and then you start creating things like a sketch, which I started with just a circle, 2 circles here actually around the eye of the hook. I moved forward from there and extruded that sketch into a solid, which you can see this view here, and just kept moving forward. After that, I rounded it on the outside, rounded it on the inside. As you can see, I'm kind of getting the shape of the eye of the hook at that point. And then I created another sketch and basically just used a spline tool to get the center line of the hook. Put an offset plane, this is a plane here perpendicular to this line on this point that I used to create another sketch, which you zoom in. This is a circle right here that you can see that's the actual diameter of the hook. After I created that, I used a sweep command, I believe it, or maybe, I think it was a sweep command or pipe command, I'm not sure, one of the 2. And it basically creates that cylinder along that path, which was that spline that we made. So at that point, we pretty much have the basic outline of the hook. Continued to just refine it some just because I'm picky. Really didn't have to go as far as I did into this. Anyway, I kind of worked on the eye here a little bit more to get it a little more accurately represented. I added that little piece there in. After that, I decided I wanted to put a point up here, which you really don't have to do for making the jig mold, but I did it anyway just to give it shape, by using cutting tools. Added a barb in, and at that point, I decided to make sure I had it accurately modeled. I drew a rectangle around it pretty much, as you can see, and then extruded that rectangle to about 1/8 of an inch thick, I think it is. And then I used the hook itself as a cutting tool If you look at the front view, you can see how it's lined up right at the center line of the hook, that solid rectangle I made. And I used the hook to cut out the space that it occupied basically in this rectangle, which you can see if I turn the hook off. It created basically a hollow body there that I was able to print. And basically I sent this to my printer, printed it out, which gave me this here. And I was able to drop that hook right in it, like so. And see that, yes, I did have it accurately modeled. I just wanted to double check, but it fit right in that little groove just as pretty. So I knew everything I had done up to this point was correct. So I proceeded from there. Like I said, I did this with several different sizes of hooks. Okay, so once I got the hook, the first thing I did was create a jig, a bottom jig for catching like tautog and stuff like that. But I wanted it to be really durable. So I put the extra strong hook in it. And I wanted it to kind of be shaped like the body of a fiddler crab or a crab in general, the actual jig head itself. So what I did is I brought in a picture online I found of like a fiddler crab body. And then I drew a sketch around that to kind of mimic the shape of it, as you see right here. And then I used that sketch to create a form out of the form tool. And once I got that, I started using all these lines and stuff to basically make that form look the way it does. Let me turn this and this off, and I ended up with this form right here. It's basically the kind of the shape that I wanted. Looks a lot like a boxing glove jig, I admit. That's maybe not what they were designed after, but a little more refined, I think. Okay, once I got the body created, then I started stepping through steps of moving it around, lining it up, and bringing in the hook. And this is where the frustrating started to set in. Okay, I got a hook that came in, but it came in pieces from the other project. I was like, what's going on? I finally got all of the pieces to come in, but it's not where I wanted it. And I was trying to move it. Whole bunch of frustration here, just learning the software. It definitely wasn't easy. Anyway, long story short, I struggled with a bunch of steps here, unnecessary. If you see my actual history down here, there's a lot of unnecessary steps, and that was me just learning the software. And I finally copied it again. So I basically wanted an ounce, ounce and a quarter, ounce and a half, and 2 ounce sizes. So I needed 4 of them. And I was working through trying to get that right. And I finally got the 4th one up here. Still had to get a hook in this bottom one for whatever reason. At this point, I started positioning the bodies, moving stuff around, getting the hook where I wanted it in each. Whole lot of moving here, juggling sizes. It was a bit tedious, a frustrating day, honestly. A lot of Googling, watching videos on YouTube, learning how to do this stuff. Once I got everything positioned, then I really started trying to size the bodies and scale them. And that's something that's really cool about this software. Once you get this body like this, you can right click on it and go to physical material, and it'll bring a menu up over here eventually. It's a little laggy. All right, and then you can scroll down this list, like it said, if you go to metal, lead, and you can drag that over to this body. And it assigns all the physical characteristics of lead to that particular body. And you can go ahead and assign it to all of them, and you can also assign steel to the hooks. And then at that point, you can use the software itself to scale that body, jig body, up and down until you get the target weight that you want, which was really cool. So once you assign that material to it and you make some changes, you can right click on it, open up this menu again, go down to properties, and over here it'll tell you the mass of it, which is basically 0.982 ounce mass. So that would be the weight of that body right there. And then once you add in the weight of the hook itself, you should be pretty close to 1 ounce. I thought that was really cool, and it really does help you scale the sizes so the end product is actually what you want. So once I figured all of that out and got them all to where the size was pretty close to what I wanted, and I have them all lined up here, then I needed to start the tunnel for pouring the lead and all of that, which is what I did over the next few steps. Created just a little pipe there, created a funnel on top of it, as you see right there. Did some adjusting to get it where I wanted it. Figured out how to create a pattern, which saved a lot of time. So it basically just copied it in a pattern, tied it into those. I was like, all right, that looks good. So at that point, what I did is I created another sketch around the jigs, a big rectangle. So what we're doing here basically is we're not directly creating a mold, we're creating a plug, I guess you would call it. that you would use to make your mold. So you're making the reverse of a mold at this point is kind of how you think about it. So I built a tray around the jigs here, and then you extrude it up and you basically make a box that's a little bit higher than the highest point of the jigs by about 1/4 inch or so at least. I then did some further steps of like refining it by adding a taper to the wall, so the product that we pour in here to make the mold would come out easier. Rounded the corners off, which you can kind of see. Just cleaning the mold up, rounded the outside edges, put a round on the bottom of it, just to help make it look better. Once I got all of that done, I split the bodies and started getting rid of what was sticking out of the bottom of the box, which will make sense here in a second. So I'll go through all them steps. Finally got rid of all of that. Okay, so I basically have a perfect half of a mold here. So at that point, what I needed to do was create the other half. Luckily, there's a mirror command in the software that I learned how to use. And I basically applied it, and boom, it created the other half for me, except for this one body, which took me a bit to figure out, but finally got that copied as well. This could be very frustrating at times. I was like, sweet, I'm done. And I was like, oh shoot, I forgot to do alignment pins to align the molds. So that's what I did next, is I created a sketch again and made all of these little pins here, and then I copied them over to the other side but reversed them to where these are inset and these stick out. So basically the product that we get out of this plug will fit together as a mold, and these pins will line everything up. So at that point, I was pretty much done with this mold after a whole entire day of working on it. I'm not gonna lie, it took me forever to figure all this out. So this was the first one that I did. Okay, at that point I sent it to my slicing software, sent it over to my 3D printer. It printed perfectly the first time. It took about 9 hours. I did it real slow just to make sure it came out of very high quality, which it did. All right, so that was the first one. The second one I just want to go through real quick here was one that I created for Z-Man 7-inch soft plastics that I use, the swimming mullet style, for bull drum. I love those particular size baits. So I took a picture of one the same and used the same canvas and calibration technique. Brought it in, had designed a sketch. This was actually lined up with this up here. I just had moved it for a later purpose, but this is designed to fit perfectly around these curves. Went through the process, same thing, designing to put eyes in it, created the form body. Here, let me turn this canvas off, zoom in. I used the mirror command, so I only had to do one side, and it mirrored the other side for me. That way I didn't have to worry about that. But you can see through the steps, I added the eyes. Then I added scales. Took me forever once again to figure out how to overlay this stuff onto the form. Everything went good. Added the hook in, mirrored the body so it completed the other side, as you see. This one went a lot faster, because I already had experience with the other jig. Much easier. And then I just made copies of it the same. Then I started resizing, as you see, the heads. I was only doing 3 here, 1 and 2 and 3 ounce jigs. Got them all sized appropriately, worked through all of that stuff. At that point, once I had the jigs designed, it was just a matter of creating all the same stuff, which the software's trying to catch up to me. All right, here we go. And now I did kind of have an idea on these initially. I wanted the shape of a mouth, which created a little bit of a challenge pouring it because I knew it wouldn't fill up. So I was thinking, okay, I'll just do 2 pour spouts. I really messed this up because I should have had these much wider and this narrower and more connected together. Actually ended up doing away with the mouth on the jig because it just wasn't working, at least not with the product that I use for the mold. So I will probably redesign this particular mold and have it again, but it's working right now. I was able to just take a knife and cut a little bit of silicone out of these areas to get it to work and pour. But you see, I added nice bait keepers, because those Z-Mans are a pain in the butt to keep up. They always want to slide down. I actually super glue mine a lot of times. So at this point, this one was ready to go as well, and I printed it. It printed perfectly, and that's pretty much it as far as the software. So at this point, I'm gonna go out to the shop and show you what the end result of all this was. All right, folks, so here we are out of my shop with my whole layout here of stuff, and I just want to show you real quick what I ended up with once that whole inside process and printing was done. Okay, here we go. This is basically what I ended up with. This one I just printed out of blue PLA, as you can see. Turned out pretty good. The detail and all was fine. It's kind of got this black stuff on it because I painted it with a mold release agent to help the silicone to come out of it. It's basically this dropout stuff that I already had for doing jigs in the past. And here's the first one that I did, which is the jig for fishing for tautog and stuff like that, which I guess you could use it suspended as well. But these are the two plugs that I pretty much made from that whole process. What you pretty much do is once you have these here is you just buy this particular mix here called Mold Max 60. And it's a 2-part high temperature silicone. It comes with, you know, your catalyst here as well. Got to mix this very carefully. It's very specific. This stuff is good for up to, I think, 575 degrees, which is a little bit below the melting point of the lead, which the lead I think is around 675. But they say that it'll work, and it's not going to last forever. They say on average you'll get about 100 pours out of it, which really isn't bad. You basically just fill this mold up, and what it comes out looking like once you do that is both halves will look like this. Now, of course, this is already cured. Takes 24 hours for it to cure once you pour it. And I got a tip from a guy on YouTube. He takes the mix and like brushes it into all the fine details with a brush first in the jigs, and then pours the rest in real slow. And then you're supposed to like put it in a vacuum chamber to help get the air bubbles out, but I honestly just sat there and just tapped it like this for, you know, a good 5 minutes or so, and most of the air bubbles came right out. But once it sets up for 24 hours, then you kind of cut it loose around the edges and very carefully peel it out like that. And then you end up pretty much with this here, which is an actual mold. The 2 parts, left and right. Same thing on this one right here. And then, you know, at that point, you'll basically put, you know, the hooks that you want to use in here. Just flip it right over like that. As you see, the pins that are in there, they line it right up perfectly. It fits together. And I just took some wood to reinforce it like that on each side, just to make sure it's held together, and put it in a clamp with the hooks in there and start pouring it. Now the only downfall to this one here is it is so tall that it wouldn't fit underneath my pour pot to where I could use the built-in pour spout that this model has. So what I ended up having to do was heat it up and just dip out of the top using this ladle to put the actual material in. And like I said, I had made some design issues with this to where I ended up having to go in and cut these channels out much larger to get that lead to pour down in there and form, you know, the shapes of these here. Now the smaller one here, which is this one here for the jigs for tautog and stuff, poured with no problem whatsoever. And basically what I ended up with is these finished products over here. These are the tautog jigs that I made, and they can be used for drum, sheep's head, pretty much anything on the bottom. These I designed to actually fish on the bottom. And you see, they turned out great, pretty much just like the shape that I had kind of designed on the computer. And they used the Mustad 2X hooks, and they go all the way up to, you know, 2 ounce, which is what this one is here. Now the really cool thing about this is once I got to pouring them, I used this one here first. I was like, and the hook is actually kind of small. I was actually hoping for it to be a little bigger than that. This was a neat thing about this mold here, or these molds in general. They all had that same size hook, but I just took a much larger hook and set it in there, literally 2 sizes larger than what I designed it for, which is this 5/0 hook. Set it right in the mold like that, and you see where it kind of stuck out at the bottom down here. I just went ahead and put it together and clamped it, and because this is so flexible being silicone, it poured just fine. So it didn't have me locked in on the hook size, which is really cool, you know. And I ended up with jigs with this a much larger hook in it here, which would take a much, you know, larger piece of bait. So that's kind of neat little benefit of having the silicone. Now these are the ones that I made for the big drum. I just got very basic paint jobs, some stick-on eyeballs on them. As you see, I mean, it turned out pretty nice, you know, for something that was poured on silicone. And this is basically the finished product of kind of what I was looking for. As you can see how it fits that body perfectly. That's a 2 ounce one here, and this is a 1 ounce one here. As you see, it, you know, did exactly what I wanted it to do. And just to show you how accurate this actual software was, and this is the 3 ounce one that the keeper actually poured correctly on. And we're going to turn the scale on here and let it zero out. What you see, it's zeroed. I'm just going to drop the jig on there like so. Look at that, 3 ounces exactly. I mean, I couldn't freaking believe it. I mean, dead on. That is just impressive. That was really cool, I thought. I did have issues, like I said, with the keepers not pouring on some of them, with the inlet of the lead not being large enough, especially on the smaller 1 ounce ones. I had issues with it. So a redesign of that was definitely going to be coming, but it's good enough that I can use it now. And honestly, I could probably just go in and take some more of this material out here in the pour areas and correct that. Now, like I said, they're not really made for production because the silicone absorbs so much heat. You can pour probably 3 sets of jigs, and then you got to let it cool down because it does get hot. I noticed that, and it'll actually start kind of warping a little bit, even though it's flexible. So I would do 3, maybe 4 at the most, and then let it sit and cool in front of a fan or something like before you pour any more. But then at that point, you can just do whatever painting and stuff you want to do with it, and you pretty much made your own jig from scratch. So anyway, I thought that was really cool. It was a great learning experience for me. It kept me occupied on some days where I didn't have much going on recently. I couldn't get out and fish because of the winds mainly. I learned a lot. To me, the most frustrating thing was learning that CAD software, because I really don't have much experience with CAD software in general other than like Google SketchUp, which is way different from that. But moving forward now, I could very easily jump back in and design a jig from whatever idea I have in my head, and within, you know, a few hours turn it into reality as far as a plug, and then just buy the Mold Max 60, you know, the next day have one that's ready to pour. So literally within 24 to 48 hours, you could go from complete concept in your mind to a physical jig that you can go fish with. To me, that's just really cool. Now, once you get the design where you actually want it, if you know you want to keep that design, all you would have to do is send the CAD information out to somebody like Xometry, which is an online metal production service, and they could literally CNC you an actual aluminum mold that you could have to keep from that point on once you perfect the design that you're looking for. So this is a quick way to kind of prototype and even do low production, because even once the silicone wears out after, you know, however many pours you get, all you got to do is just make another one. Just dump it in here, and then you're good to go again if that's the way you would rather do it. It was really cool to learn it. It was frustrating, I ain't gonna lie, the software more so than anything, just trying to get the simplest things done and having to Google it and YouTube it and figure it out. It was frustrating, but I got through it. It worked, and I'm proud of what I created, and I look forward to doing it some more in the future. So if you have any questions, throw it in the comments below. I'll try to answer them. If you want a little more detailed look into the software side, I'll be glad to do that once I kind of perfect that part. And that's pretty much it for this video. Peace out. I'll see y'all in the next one.